Good morning, it's Jim from the Mavstar Observatory. Guys, we've got a lot planned for this month. As you know, I'm going to be going away on the 19th for about 8 days. Before that, I'm going to pull the SD card out of the TriMag system, the magnetosphere, and I'm hoping that by around about the 15th, we should have had Australia, both Perth, because they've both had 2 new magnetometers sent out to them, and the Gold Coast come back online, so we can start collecting data back from then. I've emailed JD in South California to see if he could do a data drop for us. I'm pretty sure Brad will be online in the next few days with his data for us. And of course there's our data coming from Hong Kong as well. So hopefully, we'll have plenty of stuff to look at. The purpose of this video, guys, before we get into it, I just want to say thank you for those people that are supporting us, because now we're building something really spectacular and adding it to our observatory, and that is the Muon detectors. So big thanks to those guys that are supporting this, because in the last month, in August, we raised nearly £2,000 towards the building of these Muon detectors. And what I wanted to say in this video is, guys, don't take for granted that we're doing this, because the level of technology is cutting edge. We are using the exact same silicon multipliers, the detector chips that collect that little faint bit of visible light from the cingular crystal that we use on we place on top of those silicon multipliers. We're using the exact same components that they are in the Antarctic Observatory ice cube, although they've got 1,000 detectors, and what they're more interested in with their detectors is not muons, but what they're called neutrinos, which are produced just like most cosmic radiation is produced from what you can see in this picture here, a blazar, big black hole consuming loads, and at either end of it we've got these big funnel jets spewing out lots of cosmic radiation. And what ice cubes are interested in doing is detecting where the trace of cosmic radiation, and more importantly these tiny nanoparticles, if you want, where they're coming from. So my point is this, guys, quite simply, we're going to soon be putting muon detectors around the world, and if at a later date we want to build a bit more of a glamorous one, we can do that in order to detect where they're coming from. And to do that, all we've got to do is just replicate what we're doing right now, only using more silicon photomultipliers. The only problem with that is it's quite expensive, so we might have to approach an organisation to fund us on that. I do know that if you get prepared to buy 3,000 of the silicon multipliers that we're using, the SIPMs, you get them down to about $24 each, as opposed to $70-something when you're buying singles, or in small amounts like what we are. So I know, yeah, even then, we're into 20s and 30s of £1,000, so it might be a way off, but if ever we get to that point, I'm sure we are going to pop up on the radar at some point for the good work that we're doing at this observatory. We might, you never know, do you? We might be doing big things and sharing those big things with other universities around the world that are in the study of atomic physics. So they are using the photomultipliers that we've got to study the origins of neutrinos in our universe. We're using our silicon multipliers, or our SIPMs, to just tell us how much cosmic radiation is in small pockets that we will place them around the world. But the thing is, guys, we're very lucky to be in a situation where we can build these muon detectors, because I always go on about this, the amount of work that went in to get the plans built for us. First of all, get the circuit boards made, designed basically. We paid for the purchase of the CPBs so that we could have those printed circuits made, and now we're just in the process of putting all the components on them. And hopefully within the next 2 weeks I'll have one built for you. I'm really keen to try and, before I have to go away on my honeymoon, get one of these actually set up and collecting data whilst I'm away. I was, if you remember, going to take it on the plane with me, but because of the country that we're going in, it's not my native language. If ever I, get stopped by their officials going into that country, and there is questions as to what this is, I could find myself, if not in a little bit of trouble, and it could ruin the whole honeymoon for us. And even though it was a beautiful opportunity to get one of these at around about 37,000 feet for a duration of about 5 hours, it would have been a great opportunity to collect the level of data at that altitude. But there will be another opportunity where we're going to perhaps another country like the United States, Canada, or even Australia. There will be another opportunity for us to put one of these Muon detectors in a flight bag or hand luggage, and just take that recording. But we do know that they are on the increase the higher altitude you go, so there is more cosmic radiation at an increased level of altitude. But guys, the main thing is we are in a very lucky situation to be building these. We're using the state-of-the-art technology, and we can improve certain things with the actual program. One of the things I'm very interested in is actually doing some work with these silicon photon multipliers, because they're used in a lot of other applications. One idea I had was to do like a tracker using the silicon, 4 of these silicon multipliers on a plate that detects just when one's getting less light more than the others, so you can put them with servos and you can have the plate track the sun as it goes over the horizon. Maybe we could mount a camera on that and select somewhere around this world where we get a lot of clear skies, and we could see firsthand without having to rely on data from NASA and the other organisations what condition with regards to sunspot numbers there is on the visible disk facing ourselves at that particular time in the day. So there's plenty of things we can use the systems for, different experiments a bit later on. So I'm just at the moment very excited and very eager to get the first ones built for us, because we are now at the observatory going into the realms of atomic physics, and more importantly hunting down that answer that we want to know is how is the Earth being affected with regards to the high and low intensities of magnetism, and in relationship to the amount of muons. So I'll leave it there, guys. I just want to say, if you want to help support the observatory, there's a link down there. It's not mandatory. You can support us on PayPal or Patreon. It's entirely up to you guys. But the most important thing is that we keep going with what we're doing, because this is our observatory, and at least we know that with the data we get, it's honestly relayed back out to you guys, and you can't get that from other organisations, because a lot of the time data with relationship to magnetism and other things, if it is serious nature, is classified. So at least for now you're going to get access to that data. So the links are down there if you want to support us with what we're doing on this new venture. We have got the cloud generator still in the process of being assembled. I'm confident that we're going to get minus 40 degrees in our environment now with the finished array of Peltiers. I'll be showing you that at some point in this week, and obviously I'll be showing you the progression of the Muon detectors, because we're going to start assembling some of the components and populating them PCB boards. So guys, just want to say, don't be complacent about where we are. We're very, very lucky to be now in a situation where we're going to be counting muons at different locations around this world, and of course we're going to be also putting perhaps at the later end of this month some more magnetometers, hopefully in Brazil and South Africa, so we can get data coming from those regions as well. Okay guys, I'll leave it with you. You have a great Sunday, and I'll catch up with you maybe tomorrow. Okay, as always, bye for now.